So we are back to our main room.
Done.
So how was the experience?
Nice, madam.
Okay, so could you share your screen and show the commands? All of you, like one of you can, few of you can talk. Okay, Priyanka is saying good. Okay. So we'll start with the descriptive. Okay, so Prasanna, I think by mistake, we are in the breakout room. So all of you, please, we are back into the breakout room, and I just, sorry, in the main room. Breakout rooms are now closed, so we are back to the main room, and we are starting with the descriptive statistics. And with this, I don't think that today we'll see that whether the breakout room is possible or not today, because we are running a little late. So this is the this was the data sheet which you saw in the initial exercise. So descriptive statistics is basically a procedure, because any data set which is there, you first need to perform a descriptive statistics. Even before the applying the t-test or Wilcoxon or Mann-Whitney U, because if you see any difference in the descriptive, then you take a decision whether to apply or which type of test to apply. So descriptive statistics is the first statistics which you should be doing in your data. So it is basically a procedure to summarize your data in a meaningful way, and it guides you further in your analysis what to do and what not to do. So descriptive statistics, which is also known as a summary statistics, it is describing the data, and it is basically of 4 types. So this descriptive statistics is like, we'll see it is a mean, median, and mode. Then there is a variability, then there is a range, and then there is a dispersion. We'll see all these one by one. So the advantage of this descriptive statistics is that there's no uncertainty, because you are not predicting anything. You don't give confidence interval. So there is no uncertainty with the descriptive statistics, because you are not making the predictions about the population. You are only describing your sample statistics. But there is a limitation that it is the summation of only those people who are there in your sample. So there are basically 4 types of descriptive statistics. First is the measure of frequency, which is also known in the GEMOV. I think by mistake. Okay, just for now. So we are taking the screen sharing, right? Probably because by mistake, I think people are sharing their screen, and that is interrupting. Yes, so can you see my screen? So first in descriptive, we'll see that we measure the frequency, which is like in the form of a count or percentages. We make frequency table. We'll see how we make in the frequency table in the GEMOV. So that count or percentages or measurement of frequency, that is one of the type of a descriptive statistics. The second is the measurement of central tendency. So this central tendency is like when you give your result in the form of a mean, median, that is your central tendency. The third type of descriptive statistics is the dispersion. So dispersion is described in the form of a standard deviation, interquartile range, or range, like how spread your data is. And then the fourth is the measurement of position in the form of a centile or in the form of a percentile. Like we express the data in the form of a first 4 quartile, or maybe the centile, or maybe the decile. So depending upon the equal division, When it is in the 4 equal division, we call it as a quartile. When it is a 5 equal division, so every 20th, we call it as a quintile. So depending on the position, you express your data in the form of a percentile. So in descriptive, we do 4 type of thing. We do the frequency distribution, which is the count and percentages. You give the mean and median, which is the central tendency. You give the dispersion, which is the standard deviation or interquartile range, or you give the position, which is the percentile. So descriptive statistics, you describe only about the sample. You don't try to infer about the population, and you don't do the hypothesis testing. Hypothesis testing you do in the analytical, or you do in the inferential statistics. Inferential statistics is when you describe about the sample, but you project about the population. So you infer about the population from your sample data, and you do the hypothesis testing also. So in the inferential statistics, you have got a null hypothesis, you have got an alternate hypothesis, and then you see whether you reject the null hypothesis or you accept it. And the strength of inferential statistics is that through this, you are trying to project the population estimates. So population estimates can be obtained, but there is one disadvantage, that there will be an element of uncertainty. And the element of uncertainty is that we talked about the sampling error. Remember, in the first session, we talked about the sampling error, that larger the discrepancy is, more the sampling error. That's why if you take an adequate sample size, if you've got a large sample size, then this sampling error is less, and then this element of uncertainty is also less. Coming to the inferential statistic, again to summarize, in this case, you describe about the sample, you infer about the population too from the sample, and you do the hypothesis testing, which you don't do in case of a descriptive statistics. So we have again done, it's just the repetition, that it's the frequency distribution, the central tendency, and then we measure the variability. So frequency distribution is like you make the frequency table and you give the graph also. So we'll see the histogram and bar diagram are there, and we give the percentile also. So measurement of central tendency is like mean, median, and mode. We all know that if the data is normally distributed, we take mean. If it is skewed, we take the median, and mode is the greatest frequency. For example, this is the 10 individual, and this is the cholesterol value of the 10 individual. If you take the mean value of all these, you will sum it up, and the mean value of these 10 people are 186.6. So and the mode is 220, because mode is appearing twice. So you can see one is 220 is this, and the another is here, it is the 220. So it is appearing twice, that's why we call it as a mode. Now coming to the other median, how will you calculate the median? So this is just, we are telling this by example, otherwise a software tells this and it does not. You don't need to do this analysis. In the background, the software does this analysis and you only need to apply the command. So this is mode, and in this case, you can see that if you have to calculate the median is the central value. If you arrange the data in ascending or descending order. So this is the data in the ascending order. If it is an odd in number, you take the middle value, but since this 10 is the even, so you take the middle two values and you do the average. So the fifth and the sixth value, you do the averaging, and that is the median. So this is how we calculate the median. So now one this thing for you. So you guess the song by this picture. All of you, please write in the chat box. Anyone? A very favorite, a very Kesariya. Pehla Nasha. Okay. So it is requested from the AIMS Patna facilitators that don't write the answer, because I hope you people know, but let the participants first write. Okay, so I was thinking like whether the younger generation, I don't know whether they know it or not. So true, it is the Pehla Nasha. So now coming to this normal distribution, if you see this normal distribution curve, we all have read in our UG's days that it is a bell shape in curve. So you can see it is again like a bell shape. Why it is a bell shape? Because we know that most of the biological variable, they tend to cluster around in the central. So that's why there is a more number of people in the central and less towards the end. That's why it's like a bell-shaped curve. And in a bell-shaped curve or a normal distribution, this mean, median, and mode, they coincide. Mean is a very sensitive measure, and it is affected by the extreme values. That's why if your data is skewed, we always prefer to take the median value. In case of a skewed distribution, in case of a normal distribution, you can report both mean and median because they will be either the same or very slight difference will be there between the mean and median. But in case of a skewed distribution, like in this case, you can see this is a skewed, and skew is by the direction of the tail. So this is the tail. If it is towards the right direction, we can say that it is the right skew. And you can see that in this case, it is preferable to report median and the interquartile range because mean is dragged in the direction of skew and median is not affected by the extreme value. So now measurement of central tendency, you can see here that the type of variable, if it is a nominal variable, we always express it by the mode, which is the frequency table. And then ordinal, if there is a data is ordinal or the variable is ordinal, we prefer mean. And in case of an interval and ratio, if it is not skewed, we give mean. But if it is skewed, then we give median. So this is how we report about the central tendency. Coming to the measurement of spread, like we did, spread can be measured by the range, which is the maximum and minimum value, standard deviation and variance of a population, and standard deviation and variance of a sample. So this variance concept, we will learn more in the ANOVA, which is the analysis of variance. But right now, you just understand that the square of standard deviation is the variance. So this is one example. You can see the same 10 individual where we have calculated the mean, median, and mode. So mean, if you can recall, it was 186.6. So I have deducted the mean. So this is example. I'm just demonstrating how the variance is calculated. You need not to calculate it. The software does it. But just to make you understand how this is calculated even by the software. So this is a 10 data, like in data of a 10 individual, and these are the individual cholesterol values. So the mean of these 10 individual cholesterol value is 186.6. If you deduct this from the individual value, this mean, so these are this value minus this mean, and this is the square of this difference from the mean. So variance is explained as the sum of square divided by total number of sample minus 1. So if you like add it, the whole thing, the sum of square will be 9542.4. And if you divide it by 9, the variance will be 1060. If you take a under root of this, then the standard deviation comes. So have you understood how to calculate the variance or how the software does it? So software basically, the individual mean, the distance of the population mean from the individual mean, if you square it, it is the sum of square. That's why this sum of square is there, and then you divide it by the number of sample minus 1. How do we calculate standard error? So standard error is the sigma by under root n. So sigma is the standard deviation. If you divide the under root of population, standard deviation by under root of sample size, then it gives the standard error of the sample. So now coming to the normality of the data. So we know that we should report the median, and there are parametric and non-parametric tests. So parametric tests are those tests which can be applied if the data is normally distributed, and non-parametric tests are those tests which we cannot apply if the data is not normally distributed. So that means before we apply any test, it is important for us to check the normality of the data. So how to check the normality of the data? So like there's a question like you have measured the blood pressure of 5 individuals and SGOT also of the 5 individual. So how to decide that whether you should report mean or median, or how to describe your data? So like this is the 5 data set. The blood pressure measurement as 110, 108, 120, 122 and 100. SGOT levels are 10, 110, 8, 210 and 12. So in this case, you can see what is your interpretation. Please write in the chat box. Just by seeing the data set, can you say like which seems to be normally distributed and which seems to be skewed in distribution? So SBP normally distributed? Yes. So right. So systolic blood pressure is normally distributed, and there you can see like very low values and high. So there is a SGOT is skewed. So rightly said. So this is like if you have got a small number of data set. But if you have got a huge data like maybe 100, 200, then you cannot go and check the individual values. Then it is difficult for you to decide just by seeing the data. It was easy because there was only 5 samples here. So how to decide whether the data is normally distributed or not? So in this case, so before I go with the test, how to apply that and how to check that, you have to do this for me, that you have to find one difference between these 2 pictures. No tail. Very quick. Very quick. True. So thank you. So we'll move ahead. So the values in a continuous data set, it can have a normal distribution or it can be a skewed distribution. So if it is a normal distribution, we express it in the form of a mean and standard deviation. If it is a skewed distribution, we express it in the form of a median and interquartile range. So normal distribution, I have again, I'm just repeating this concept that it has been seen that most of the observations, they cluster around the central peak, and the probabilities for values further they taper off equally in the both direction, and most of the natural variable they follow this normal distribution, which is like height, weight, BP and IQ. So there are objective ways and there are subjective ways to know about the distribution of data. What are those ways? So if you go towards the numerical method or objective way, this objective way is sensitive for low sample size. Then how low? So according to Lerd, it quotes that 50 is the cutoff. So if the cutoff is less than, if the sample size is less than 50, you should use the objective way of the assessment of normality. If the sample size is more than 100, you should use the subjective way to assess the normality. So now what are the objective ways? The most important objective way, although it is written in the last, is the Shapiro-Wilk test. And Jamovi or SPSS, they both give this value of Shapiro-Wilk test. This skewness and kurtosis, this comes after this Shapiro-Wilk test. So there are 3 ways objectively to decide about the data, whether the data is normally distributed or not. And this is the Shapiro-Wilk test, kurtosis and skewness. This is an objective way. I'll tell these one by one. Now there's another way, that is the subjective judgment. So this subjective judgment is a graphical method. The first one, the objective, was a numerical one. But this is a graphical method. And in this case, a little more experience is required because you have to observe the plot. Many times it may lead to confusion, that one of you will say that it is normally distributed. The other might say that it is not normally distributed. That's why we say that it is a subjective way of assessment. It is generally used if the sample size is more than 50, and the methods are a quantile plot, which is known as the QQ plot, and histogram. You must have heard regarding the histogram. This QQ plot, we'll see how to do that. So, 3 ways to assess objectively the normality of the data, that is the Shapiro-Wilk test, Shapiro-Wilk test, kurtosis, and skewness. And this is a numerical method applicable when the sample size is less than 50. The other way is the graphical method or the subjective way, applicable when the sample size is more than 50. And the 2 ways are the histogram and the quantile plot or the QQ plot. So like this, you can see these both are the bell-shaped curve. So this is normally distributed. And in this case, you can say that one is skewed and the other is normal. So coming to the Shapiro-Wilk test. So Shapiro-Wilk test, in this case, the null hypothesis says that the data is normally distributed. So in most of the time hypothesis testing, you always want your null hypothesis to be rejected. And in that case, your p-value will be always less than 0.05. But Shapiro-Wilk, since the null hypothesis states that the data is not the data is normally distributed, so we will want, or it is desirable that the p-value should be more than 0.05, because we want our data to be normally distributed. Then only we can apply so many parametric tests. But since the data, this p-value here, so our data will be normally distributed if the p-value for the Shapiro-Wilk test is more than 0.05. Please remember this. If the p-value of the Shapiro-Wilk test is more than 0.05, then the data is normally distributed. The next, it is suitable for the sample size less than 50. That we have discussed. Objective ways are suitable for sample size less than 50. So these are some normal distribution graph. You can see here the graph is normally distributed. Standard deviations, this is more spread. So dispersion is more. That's why there is a difference. First case standard deviation is 15. In the second case, the standard deviation is 30. Whereas the mean for both the sample is same. That is 100. So coming to the second way, that is the skewness and kurtosis. So skewness, what is a skewness? Skewness is the horizontal symmetry. So if the skewness actually measures the symmetry of the curve. So if the curve is symmetrical, the value of skewness is less. If the curve is not symmetrical, that means there is a skewness. So it is measured with the direction of the tail. So we have learned that it is a right skew, then the tail will be towards the right. And if there is a left skew, then the tail will be towards the left. So there is no symmetry, then we call that it is a skewed data. And this, if the value of this skewness, if it is more than 2, and it could be plus or minus, because plus will be towards the right skew and minus will be towards the left skew. So there is a value, we'll see in the JAMOV, it gives you the value of skewness and kurtosis. So if the value of skewness is within plus minus 2, then we take that data to be normally distributed. The second is the kurtosis. So kurtosis measures a peak. So if the graph is very peaked, it is the kurtosis. There are 2 types of kurtosis. If there is a less peak, we call it as a platykurtic. If there is a more peak, we call it as a leptokurtic. The value for kurtosis is also same. If it is within plus minus 2, we call it as a normally distribution. So remember, for Shapiro-Wilk, we say that the p-value should be more than 0.05. Then only the data is normally distributed. For skewness and kurtosis, the value should be within less than plus minus 2. Then we can say that the data is normally distributed. Kurtosis is regarding the height of the graph, and skewness is regarding the symmetry of the graph. So now there's one this thing for you. I'll share my sound. This thing, and you have to guess which Bollywood actresses. So yes, started Tagore. So you have to say which Bollywood actor and actresses appear in this song. Sorry. मिले सुर मेरा तुम्हारा तो सुर बने हमारा सुर की नदियाँ. Many celebs. Sharmila Tagore, Radha. Yes, Amitabh. One said Amitabh. Rekha. Nutan. No, I don't remember Nutan. Answer will reveal our age. Okay. True. Mithun. Yes, Hema Malini. Shabana. Kamal Hassan. Okay, yes, Sharmila, if I can remember, Sharmila, I think there was Jay Balaya, what she has written? Jay Balaya. I don't know, what is that? Okay, Jitender. Chalo, good. So we'll go with this kurtosis and skewness. So you can see that this is like we were telling you that if it is towards the tail of the direction is towards the right side, we call it as a positive. And this is tail towards the left side, this is called as a negative skewness. So if value will be less than 0, if it is a negatively skewed, and if it is positive, then it is a more than 0. Similarly, this is more pickedness and this is left pickedness. So this is regarding the kurtosis. So this was regarding the objective way of assessment of normality. Now coming to the subjective way, we have got two ways, that is the histogram and quantile plot. So histogram is like when you arrange this, and if it appears like a normal bell-distributed graph, like a bell shape, then we call it as a normally distributed. So these appear to be normally distributed. Coming to QQ plot, so QQ plot is the one of the best method, and the Jamovi also gives this as one of the method for the assessment of normality graphically. So if your data is normally distributed, there is a diagonal. So your circular dots, which are your data point, they will be positioned approximately along that diagonal line in normal QQ plot. So you can see here that these dots, these are the individual data point, and they are along this diagonal line. So the dots are distributed across the diagonal line. So this is normally distributed. Similarly, this is also normally distributed. So now there is something known as so Ashok Kumar is writing difference between objective and subjective. So now this question, can any participant answer this question? I have shown you that two similarity and dissimilarity. So the difference is basically, first is regarding the sample size. If the sample size is, yes, Farhat is writing objective way used when the data is less than sample. True. If there is a less than 50, then it is the objective way. Again, objective way will have less variability, because if the p-value is like 0.05, it will be same for you or for me also. But when you see graph visually, I'll show you, once you see those graph, you can appreciate that there can be a graph where you say, no, this is normally distributed, and the other person will say, yes. So Priyanka is also writing that subject is by experience and sample size is by 50. Again, this objective way is very sensitive to the higher sample size. If you will see the Shapiro will, it will always be significant in larger sample size. So if you take the Shapiro-Wilk value, it will say that the data is not normally distributed because it is very sensitive. it becomes significant the moment the sample size crosses 50. That's why these are some basic differences between the objective and subjective way. Yes, Ashok, Dr. Ashok, are you able to understand this, or is this justification is acceptable to you? Okay, thank you. So now coming to box plot. So there is something known as the outlier. We will read outlier more in the independent sample t-test because that is very sensitive to outlier. But still, you should report outliers also. And outliers are reported by the box plot. So now what are these outliers? Outliers are the data point. If you can see this, this is box plot, which is also known as the box and whisker plot. So in this case, you can see that this is a box and these are the whiskers, this end. So box and whisker plot is basically for the outlier. In this case, there will be a dark line. So this dark line in the box is the median. And not necessarily that it will lie in between, the distance you will see that it may differ. The 25th percentile and 75th percentile, which is the Q1 and Q3. So this breadth of this interquartile range, it's the breadth of this box. Then you can see that there are two lines which are the whisker. So any data point, so these are the two which we take as the minimum. So minimum is this Q1 minus 1.5 interquartile range, and this Q2 minus 1.5 is plus 1.5 interquartile range is the maximum. So these are the 2 points, and any data which falls outside these two, 1 point like Q1 minus 1.5 interquartile range. So 1.5 times this box length, if a data falls beyond that, that is known as the outlier. So this minimum minus 1.5 interquartile range is a point. Then again, there is a point defined as the maximum, which is the Q3 plus 1.5 times this interquartile range. And if any of the data set that lies outside these two, maximum plus 1.5 and minimum minus 1.5, it qualifies with the outlier. So this outlier in the Jamovi also, it is by the number, and you can take a call whether to keep those outliers in your data analysis, then do the analysis, or remove that outlier and then do the analysis. But at least you should report the outliers. How many outliers are there in your data set? So now I'll go to the question. So this is the question I have to show you the first. So in the descriptive, we have learned that first we show the count and percentages, which is the gender-wise distribution of patients, and then age-wise group distribution of patients, distribution of patients according to smoking status and comorbidity status of the patient. So this is the dummy table which we have created, and you have to write the interpretation also. So I'll go to the data. So this is the data set for the demonstration of this descriptive statistics. So you are now familiar with the Jamovi interface. This is a dynamic interface where on the left side panel, you can see the data. On the right side panel, you can see the result. Then you can come to this analysis. If you click this analysis, and if you go to this exploration, you can see there's an option known as the descriptive. You click this descriptive, then you will see there are two windows here. There's a something known as this is the variable, and this is the, if you have to make a like split group. So we will first do the frequency table. So you can see there is something known as the frequency table here. So can you see this one? So you have to click on that because it is right now unchecked. So that's why you uncheck, you should check this, and then I have to enter in this, you have to enter the categorical variable. So maybe gender. Then if I have to go by the social, so I'm just first telling you the frequency table. I am not showing you the statistics and plot first. If you click on this, then you can see by this, by default, these are clicked. Like you can see mean, median, mode, standard deviation, minimum and maximum. So I don't need these variables for my categorical variable. So this I have, this maximum also, I have unchecked this because by default, this is checked. So now this is my table. And if I go to the question, I have to show you the gender, age, smoking, and comorbidity. So gender, then again age category. So remember, we have made the age category. So age category, let me see where it is that. So I think it is not there here. So maybe the total number of categorical variable like these socioeconomic status you can enter. And then you can have this other comorbidity like hypertension, diabetes, cardiovascular disease, stroke, COPD, CKD. So these can be there. And then the moment I enter these variables here in this variable box, you can see simultaneously the results are populated here. So in this case, you can see it is 27.8 female percentage, then 72% of male. Similarly, frequencies and percentages of these variables will appear here. Diabetes, hypertension, and then you can see cardiovascular disease, stroke, and then you can see COPD, CKD, these will appear, right? So this is the frequency table. And in this case, you can see there is one more option here, that is the variables across the columns. So this is the variables across the column. And in case you can change this also if you want it across the rows. So it will be changed. You can see in the later part also when you have this. Right now it will not have much effect because we don't have anything across. So now if I split this, because there's only one variable, if you split variable, that will see in the mean and median. But this option is there, remember this. And then this I have calculated the frequency. So if I have to analyze, write it in the description. So this is like male and female. I have written like count and percentages. Interpretation, you can write like male outnumbered the females. Similarly, if you see, I have entered this is the age group wise distribution and this is the write-up. Like maybe you can write that the proportion of study subjects belonging to 30 to 60 years of age category was 67.7. So majority is lying in this category. That's why you can write these things here. So this is the frequency table. Now coming to the across this thing. So if I go to the questions, comorbidity status. So comorbidity status, again, you need to merge this. So you can see here, there are many which I have entered. If you go to the JAMOV, I have entered all the variables like COPD, stroke, but just for demonstration, we have taken these three variables like diabetes, hypertension, and COPD. And you can see like no and yes category, you can see count and percentages of these comorbidity status, and then you can write interpretation. You can write like that proportion of the diabetic in the cases were like 22.2%, hypertension 33.3%, and COPD was 31.1%. And this was with the frequency table or the counts. Now coming to the frequency table across. So now if you want the gender-wise distribution of patients across the outcome or age-wise group of the patients across outcome or comorbidity status of the patients across outcome, then how will you do that? So maybe what I'll do, you can go back to JAMOV, and in this case, I may move these variables will be there, And in that case, I can have this outcome in this split. So outcome is a categorical variable. You can see by this sign of flower that this is a categorical variable. And then you can see it gives you the like diet, all the proportion. So you can see like in discharge and diet, females in discharge and diet, similarly male in discharge and death, frequency of diabetes in discharge and death. And in this case, if you want to change it, then you can again change it across the rows. Then in that case, it will appear like this, the upper one. So this, and how to enter that in the table form. So this is the gender-wise distribution of patients across the outcome. So discharge and death. Similarly, you can see the age category that is again in the discharge and death. And similarly, you can come down and see the comorbidity. So we have entered like diabetes, no, yes. But in this case, there is one problem that this doesn't give you this cross tab, plain cross tab here or across this split, it will not give you the percentages. So you may get it by the chi-square frequency table, which we will do tomorrow, not today. So for today, you can either do it manually or you can just see the numbers and we will show how to get the percentages in the chi-square. Because ultimately these percentages are not meaningful unless and until you test them statistically. So that's why you need to put chi-square also if you are using this 2x2 table or 2x3 table. So this is regarding the frequency table. Now coming to the other, if the data is continuous variable, then we may need to calculate the mean, median, standard deviation and the interquartile range. So after that, I have to do the normality testing of these continuous variable. So, okay, so now I'll start because with the categorical variable, you don't test for the, so once I move, so you don't test for the distribution because the normal distribution is tested only for the continuous variable or for the interval and ratio type of variable. So once I move these variable back to the window, you can see that all the results, it will disappear. So in that case, what should I do? So I can have a duplicate, I can duplicate the result. So what I'll do, I'm just showing you once again. So like I have entered this and there is a frequency table. So the moment I want a descriptive statistics, I will move these variable back to this window. Then this will disappear. So to avoid that, you can select this, not this, all the analysis, do the right click, analysis. And in analysis, you can click this option of duplicate. So if you duplicate this will be there. If you scroll up, your previous analysis will be saved and this will open a new window. So now this is the active window. And even if you remove this back again, this will disappear. But the upper results, these results which you have saved or which you have duplicated, those will be there. So now I will uncheck this because I have to test the distribution of the variables. So for example, for demo purpose, I am showing you these three: BMI, cortisol, ferritin, and LDH. So maybe you can test all variables, but I will test this BMI. So this is the BMI. Then there is a cortisol, then LDH and ferritin. So if you go down, you can see there is an option of plot. So in the plot, you can see there is a histogram. There is an option of QQ plot. There is an option of box plot. And there are other like violin plot and bar plot, but we are not discussing that. So what I'll do, I will click, since sample size in my case is how much? 180. So for 180 sample, I will not be using the Shapiro-Wilk. But with this, it will give you. In this case, you can see the normality testing here. This Shapiro-Wilk option is here because Shapiro-Wilk is a value. So it will not come in the plot. In the plot, it will be the QQ plot. So for your this thing, I'm clicking this also. So you will come to know why this Shapiro-Wilk is not sensitive. It is very sensitive for the large number of data. So I will click first this QQ plot. So if you see the value of Shapiro-Wilk in all the case, see, in all the case, this p-value of Shapiro-Wilk, it is more than 0.0. It is less than 0.05. So if you go by the value of Shapiro-Wilk, what does it say? Are these 4 variables normally distributed or skewed? Except cortisol. So BMI is also, it is saying that it is skewed. Okay. So now coming to QQ plot. Now see this BMI score. In QQ plot, what we learned that along this diagonal line, if most of the data points are across this diagonal line, this is normally distributed. So this is a normally distributed graph, this BMI. This cortisol, you can say that this is normally distributed. Again, you can come down. What about your LDH? So if you see this, this is not normally distributed at all because there are a large number of data points which are not across this diagonal line. Similarly, if you see this ferritin, in this case also, there is a large number of data points which are not normally distributed. But if you go by the value of Shapiro-Wilk, it will say that these are also normally distributed. If you enter more variables, like just for exercise, like if you enter this, even vitamin, this SGOT, then also say that SGOT also says, if you see the value of Shapiro-Wilk, that it is a skewed one. It is normal distributed. But if you see this SGOT, the QQ plot, you can see that it is all the data points, majority of the data points are not across this diagonal line. So this is not normally distributed. So that's why we emphasized that for a data set, larger data set, the value of Shapiro-Wilk, mostly it will be less than 0.05, and you will conclude that the data is not normally distributed, whereas the data is normally distributed. That's why Shapiro-Wilk is not recommended for a larger data set, and that how large? That is the cutoff is 50, more than 50. Similarly, coming to the other options, which is the, if you are getting confused, you can also apply more than one ways to check the normality. So you can again click on this histogram. And if you click the density plot, it will give a superimposed curve. So you can see again with the histogram. So every QQ plot will be followed by a histogram. So like this is the histogram of BMI score. And then you can see this is the for cortisol. This will be the LDH. And then this will be your ferritin. You can see it is not normally distributed. Now, coming to the other, you can see there are other things also, this skewness and kurtosis. You can check that values also, but it is not needed. The most important is the Shapiro-Wilk objective criteria. But again, as an exercise or as a learning, you can see the value of skewness and kurtosis. So you can see the skewness, it is within 2. Except this LDH, you can see it is as high as 9.95. Again, with the SGOT, you can see it is 2.89. So, and if you see the kurtosis, you can see kurtosis is also high. With the SGOT, you can see the kurtosis is 10.5, which is more than 2. Here also it is very high. So these are the values which suggest that this is not normally distributed, even the ferritin and SGOT. Now coming to the box plot, because we learned the box plot also. So click on this box plot. And you can see, so this you can see like number of outliers. So there are 6 outliers or 7 outliers here. Here also you can see there is no outlier in cortisol because no data point is appearing. In this case, you can see these are the outliers. And in this case also there were many 3 and 2, 5 outliers. So if you need to comment on the normality, here also you can see there are many outliers. So you paste these graphs. So you can do the right click, copy these graphs, because this is like a MS Word. You can go back, like I have pasted, you can see I have pasted the QQ plot of these BMI, cortisol, ferritin. You can show it up and you can write that the BMI, the cholesterol, they were normally distributed, whereas the vitamin D, SGOT, they were skewed in distribution, as evident by the visual inspection of the QQ plot. So this is how you can comment on the normality. Am I making sense to all of you? Are you getting the nag of this QQ plot, kurtosis, or the Shapiro-Wilk test? Okay. Then I can go to the other thing. This we have done the normality. So now again going back to the question. So next exercise is descriptive statistics. So I have to do the descriptive statistics of BMI, the serum ferritin, and then various other clinical parameters. Yes, more the number of outliers, more the skewness, definitely. If there are many outliers, so that's why we always, in one of the assumption, we'll do these things more in the independent sample t-test and in the paired sample t-test. More the number of outliers, more the skewnesses as compared to the data. So if there are like sample sizes 180 and if there are like 20 and 30 outliers, and that there is no fixed percentages like how many, but you have to make a comparison between your box plot and your QQ plot regarding this. But definitely if there are more number of outliers, there will be more skewness, as we have seen with that 5 data set in the initial example. So coming to the descriptive statistics, so now I have, with this, we know that which are the data which is normally distributed and which are the data which is skewed. So you can now click on this mean, median, and you can click on the interquartile range and the standard deviation. So in the table, you can see the data, it will be populated. Here you can see the BMI, cortisol, the mean, median, standard deviation, interquartile. I will uncheck these which are not needed. Maybe Shapiro will now just for demonstration. So you can see that mean, median, standard deviation. There are 11 data which is missing. Here there are more data which is missing. And then you have to report. So you know that the SGOT, ferritin, LDH, they are skewed. So you should report the median with interquartile range. And for BMI and cortisol, you have to report the mean with standard deviation. So that's what we have written here. Like with BMI of patients, mean is 44 with standard deviation of 16. Similarly, you can see the interquartile range, ferritin and IQR. And this is for the cortisol and other parameters. Now, if you have to do the descriptive statistics across outcome, so BMI, ferritin, and various other. So in this case, also what I'll do, these things are there. I'll just enter this outcome in the split value. So in the independent sample t-test also, you will get something like that, mean and median. But there you apply a test. Here, before you apply a test, you can see the difference. So you can see like BMI score in the diet, they were less. It is more. In the cortisol also, you can see it is less in the death mean, where it is more in the cortisol. So just the description, no inferential. So no, ideally in these case, we apply independent sample t-test, which we will do day after tomorrow. But here in this case, because we are just seeing the general descriptive statistics of these variables. So this is how, and again, then you can enter these variables in the table. Either, again, there was a question like, can we merge the table? So no, for a thesis purpose, you can use these table as such, but for publication, because the number of tables are restricted, so you will have to do it manually. The Jamovi doesn't have any option where it merges the table. Okay. So these are the things in the descriptive statistics. So is it clear to all of you? So can we use any other variable in place of outcome? Yes, you can use gender if you want, like male and female. So outcome. So like with outcome and other thing also, yes, you can keep any categorical variable. You can keep gender. It will make a little this thing. It takes time. If you put two variables together, then it will do a layering. First, it will give the under the discharge male and female and died male and female. This was the question, Anju. This is how you wanted, or your question was something different? Okay. No, you have written in place of outcome. So in that case, you can remove this. Then it will be only with the gender. Okay. If you want layering also, then in that case, you can do both these together. You can use any other categorical like socioeconomic status also. It will be a huge table, like for each variable, it will give you. Okay. So that's the thing, you can do that. Any other question from any other participant? Breakout room for this activity is not possible today because we are late today. So maybe tomorrow session, we will start with the breakout room of the descriptive statistics. We'll share the video, especially for those participants who could not attend today or could not attend it completely. And it is requested from all of you to please join sharp by 2 p.m. tomorrow so that we can start and we can finish it off on time. So can we call it a day off for today, if all of you agree? Okay, Anju is writing great, thank you. So yes, okay, Prasanta is writing yes, AN, okay. So we are ending today's session and tomorrow we'll meet again at 2 with the breakout room activity. So those of you who could not get the laptop today, please try to arrange a laptop. Yes, we will share the video. No problem. By today itself. By today. Yes, we will share. We will share. You can again go through it. Okay. Thank you.